Welcome to my channel, dear student. We want to prove the formula that is for the chapter of gamma beta function, that is gamma m and gamma 1 minus m, and that is equal to pi by sine m pi, where m is not an integer. So see, if we put here integer, then integer multiple of pi is also 0. So something by 0 is infinity. So that's why m, this is not an integer. So we have use the formula, that is the sine infinite product formula, that is pi by sine m pi, that is equal to 1 over m, and product from 1 to infinity, that is within the bracket 1 minus m square by n square whole to the power minus 1. This is the product formula for sine infinite, okay, product form. And also use the Watt's formula, that is gamma m is equal to e to the power minus small gamma m over m, that is product from 1 to infinity within the bracket 1 plus m by n whole to the power minus 1 and e to the power m by n. So now here gamma n and gamma 1 minus m, so this can be written as minus m into gamma minus m, so that is gamma m into minus m and gamma minus m. So minus m for gamma m, we can write e to the power small gamma m over m, and that is product from n equal to 1 to infinity. This is 1 plus m over n to the power minus 1 e to the power m by n. And for this, if we put here minus m, that would be plus m. Here is minus m, here is minus m by n to the power minus 1, and here is e to the power minus m by n. So therefore, e to the power minus small gamma m over m into product from 1 to infinity, and 1 plus m by n to the power minus 1 into e to the power, this is your minus, okay. And here is, I want to find the minus m here, so we can put here, this is minus minus plus m, and also here is minus m and e to the power minus m by n. So see, each and every value, if we put here 1 2 3 like that, if we pair of observation product each other, then you got here 1, so these two are cancelled out. Also from these two are also cancelled out. If we put here 1 2 3, okay, here is not depend on n, so it's simply, if we add these two power, we got here e to the power 0 there, that's why it is a 1. So now minus m, and this is here, sorry, this is here minus m, these two are cancelled out, so this is here 1 over m. So now product from n equal to 1 to infinity, and these are a plus b, a minus b, so 1 minus m square by n square to the power minus 1. So, and that is equal to pi by, this is a simple, I'll prove, easiest proof for this function, okay. Now I'm using another formula to prove this problem. See carefully, where m is belongs to 0 to 1, then see the solution of this problem. We know beta function of m comma n, and that is equal to gamma m gamma n over gamma m plus n. Here, if m plus n is equal to 1, then n is equal to 1 minus m. Therefore, beta m comma 1 minus m, that is gamma n gamma 1 minus m over gamma 1. Gamma 1 means 1. So gamma m into gamma 1 minus m. Okay. So bm comma n, and that is beta m comma 1 minus m, and that is equal to this is the beta function, and this is here if mn, so that is gamma m gamma n over gamma m plus n. This is the formula here from 0 to infinity. Here x to the power m minus n over 1 plus x to the power m plus n. If this is m plus n, this is 1, so this is from 0 to infinity, so x to the power m minus 1 over 1 plus x and dx. Okay, so then we got here beta m comma 1 minus m actually. So for this problem we want to find from 0 to 1 x to the power m minus 1 over 1 plus x and dx, and this is from 1 to infinity, that is x to the power m minus 1 over 1 plus x and dx. Okay, now n approach to infinity, then for this integral, okay, for this integral, let us assume this is a I. So now I is equal to 0 to n and x to the power m minus 1 over 1 plus x and dx. Let 1 by x equal to 1 by y, so implies that 1 over y square minus, and this is dy. And see, if we put here n, so this is 1 over n, okay, this is 1 over n, okay, I am wrongly written here, this is 1 to infinity, so this is not 0, this is here 1, taking it wrong. So if we put here 1, so we get here the value of y is 1, so this is x means 1 by y, so y to the power minus m plus 1, okay, 1 plus 1 over y, and this is minus 1 by y square, and this is and dy. Okay, simplify, and that is equal to, so 1 to infinity, sorry, 1 to 0, 1 to 0 as n approach to infinity, so 1 over infinity is equal to 0. So if we simplify, so this is here minus, so changing the limit from 0 to 1, okay, this is 0 to 1, and y to the power minus m plus 1, and this is here y plus 1. If we y are cancelled out, so only 1 by y have left here, so this is to the power minus 1, so this is minus m only, this is dy, and that is equal to, if x approach to y approach to x, so this is 0 to 1 x to the power minus m x plus 1, and this is dx, so this is I. So therefore the our required integral from, so this is from 1, from a, this is from 1 a, so that is 0 to 1 x to the power m minus 1 over 1 plus x and dx. Okay, and same as of this two integral are same, so this is 0 to 1, so x to the power minus m over 1 plus x and dx, this is 0 to 1 x to the power m minus 1 plus x to the power minus n over 1 plus x and dx. It can be written as like 0 to 1 doing x to the power m minus 1 plus x to the power minus m and 1 minus 1 by x plus 1 and dx. So x over this, then we got 1 over 1 plus x. Okay. So then multiply 0 to 1 with 1. So this is x to the power m minus 1 plus x to the power minus m and dx. Then minus 0 to 1. Okay. If we multiply by x, so that is x to the power m minus 1 with x. So x to the power m plus, if we multiply with x to this, so minus m plus 1 over 1 plus x and dx. If we integrate, then we got here x to the power m over m plus x to the power minus m plus 1 over minus m plus 1, and this is 0 to 1. Now this is here 0 to 1. So x to the power m plus x to the power, this is x to the power minus m plus 1 into, this is 1 over 1 minus x. So expansion of that here is 1 minus x plus x square minus x cube plus dot dot to infinity and dx. Okay. So if we put the limit here, we got here 1 by m plus 1 by 1 minus m. If we put 0, 0, then got 0. So 0 to 1. If we multiply by 1, so we got here x to the power m plus x to the power minus m plus 1. If we multiply by x, this is minus x to the power m plus 1 minus x to the power minus m plus 2. Again, if we multiply by x square with this, so x to the power m plus 2 plus x to the power minus m plus 3. Okay, dot to infinity and dx. And this is equal to 1 over 1 by m and plus 1 by 1 over 1 minus m. So if we put here, if we integrate, then x to the power m plus 1 over m plus 1. This is plus x to the power minus m plus 1. So x to the power minus m plus 2 over minus m plus 2. This is a minus x to the power m plus 1. If we integrate, this is x to the power m plus 2 over m plus 2. Okay, for this is minus. This is minus x to the power minus m plus 3 over minus m plus 3. For this, x to the power m plus 3 over x to the power, okay, m plus 3. This is from 0 to 1. Therefore, 1 over m plus 1 over 1 minus m. If we put the limit 1, so you got here minus 1 over m plus 1 plus minus a minus. So for this, 1 over 2 minus m and minus minus plus 1 over m plus 2 plus minus minus plus 1 over 3 minus m plus minus a minus 1 over m plus 3, like that. Okay. So we got the series here. So this is actually 3 minus m. Okay. And this is actually the summation from k equal to 0 to infinity, that is minus 1 whole to the power k, and this is 1 over k plus m minus 1 over k plus 1 minus m, and that is the expansion of formula that is pi into cosec m pi. We know the formula. Relation, that is cosec x, is equal to, summation k equal to 0 to infinity minus 1 whole to the power k, that is 1 over k pi plus m minus plus, actually this is no minus, so okay, this is here plus, this is here plus. If we put 1, so this is 1 plus m, this is here minus, okay, and then 2 minus, okay, I wrongly written here, this will be plus. So this is here, okay, k times of pi times of k plus 1 minus m. Okay, thank you for watching my video, everybody. This is the deduction of this formula. Okay, this is the another method.